Hello, am I audible?
Yes,
Yes,
sir.
sir.
Okay. Okay. So this virtual memory can be implemented by the process of demand paging and the demand segmentation. Now, what is paging and what is segmentation, that is known to you. Okay, that I have told already. Demand paging means that if it is required, then you can go for paging. Okay, and if it is not required, then you will not go for paging. So paging on requirement will be told as the demand paging. Okay, so that means, what is the concept of paging? Paging means that you can take some data into memory whenever it is needed. Okay, so where from you are going to take the page? That means this is the concept, that is from the secondary storage you can take some data or program into the memory. Okay, and that will bring the data or the page from the secondary storage to the main memory. Okay, so it is telling that to bring a page into the memory only when if it is needed. Okay, so this question may come in the short question, that what is demand paging. Okay, or any other like question will come, so you have to answer in this way, that if the page is required, okay, if the page is required in the main memory, then only the page will be taken into the main memory. Okay, now there is a concept that is called the lazy swapper. So what is swapper? Swapper swaps the pages. Swaps the pages from the memory to the secondary storage and from secondary storage to the memory. Now this lazy swapper, lazy means you can understand that it is lazy to swap something. So this will never swaps a page into the memory unless the page is needed. So in this demand paging, basically this lazy swapper works, and this lazy swapper will not swap a page if the page is not required or not needed. Okay, this swapper deals with the pages is called pager. Means pager is to the this swapper actually is a tool, or you can say a software tool, that is required to take a page from the hard disk to the main memory or RAM, again from the RAM to the hard disk. Now what is happening here, whenever you are dealing with the pages, the swapper has a special name, that is called a pager, due to the name of these pages. Okay, it is named as pager. Now, so less IO needed and no unnecessary IO. Basically, in this case, in this demand paging, we don't have we have only the less number of IO. Okay, means input output, and unnecessary input output is not required. Okay, so less memory is needed here, and the more number of users are required here. Okay, now also there that invalid bit reference is actually abort, and whenever the page is not in memory, we have to bring to memory. So basically the concept is here that if one page is actually searched by the CPU in the main memory, if it is not present in the main memory, then the pager or the swapper will swap the page from the secondary storage to the main memory. This is called the concept of demand paging. Now the next thing is there, that is the page fault. What is page fault? If we are going to search a page in the main memory, and if it is not found in the page memory, in the main memory, then we have to take the page from the secondary storage to get the page in the main memory. That is called the page fault. Okay, and if the page is actually found in the main memory, then it is called uh, page hit. Okay, one is that page hit and the other one is page fault. Okay, so page fault or page miss means that the required page is not found in the main memory, therefore we need to keep that, we need to take that one from the secondary storage. And page hit means that the page is found in the main memory, so we can work with that. Okay, now we are going for the page replacement algorithm. Page replacement means that if the page is not present in the main memory, we have to replace the pages. Okay, so main memory has some specific size, we cannot update, we cannot increase the size. Okay, so for that we have to take one page from the main memory that will be kept in the secondary storage, and one new page will come from the secondary storage that will be coming to the physical memory. So what is happening here? In this case, you can see that, think about the diagram here. This is the particular main memory page, and this is the secondary storage hard disk. Okay, so if one page is actually found as victim, victim means what? Means that it is not required in the main memory, that will be taken from the main memory to the secondary storage so that they can be used later. Okay, and any page that is required or desired here, that will be taken in that particular location where it is from freed. Okay, so from the main memory it is freed from there, so we are going to take that one in the main memory from the secondary storage. Okay, and we have to keep, or we have to maintain a particular table that is called the page table. That page table will contain the pages that are stored in which location and the pages that are actually fetched. Okay, so these frame values are stored here, and the valid bit, invalid bits are stored here. Okay, so we can say that if a particular page is present in a frame, okay, so that we will say that valid it is. Okay, if it is not present, then we will say it is invalid. I am facing some problem with my laptop. Maybe it is turning off after some time. This thing happens. Getting locked due to heat. Okay. So I'm going to uh, do this thing early. Okay, I'm going to go to the particular problem here that will come in the examination. So just see this one. Can you hear?
Yes, sir.
Okay.